Hello and welcome to today's lesson. We're going to be covering topics under the standard 1.4 in 6th grade and topics under the standard lesson in Study Island called Solve Equations. And basically what you're going to need to know today is what opposite operations are. So addition and subtraction, they undo each other. So those are opposite operations. The same with multiplication and division. And as we're going through these videos, please be sure that you're taking notes so that you can have examples and notes to look back on when you're trying these problems on your own. And if I ever go too fast, just pause the video, take your notes, and then unpause and catch back up. And you can even pause at the beginning of the question, work the problem out yourself, and then watch the video to see if you get the same answer. And if your answer is the same, then you know you're doing fairly well with these examples. And if it's not the same, then you can see where it is that you need to study. So I'm so glad that you joined us today, and let's go ahead and take some notes. In 6th grade, we start off with one-step equations. So that means you just have to identify what the operation is in the problem. So it's either going to be addition, subtraction, multiplication, or division, and then do the opposite. So if you have a variable that has a number added to it, you're going to do the opposite, which is subtracting that number from both sides. If you have a number that is being subtracted from our variable, which is x here, then you're going to add that number to both sides because subtraction and addition are opposites. And then here we have multiplication, and multiplication is often shown by 3 and then followed by the variable. So this 3n, there's the invisible multiplication symbol is implied here. And the reason for that is when you start looking at letters in math, having the x for the multiplication symbol can be confusing because we also use x as a variable. So we don't want to get confused, so we just leave it out. So this here is implied multiplication. So we use a fraction bar to show the division to both sides. And when we see a fraction bar, we just need to remember that that's a symbol for division also. And the opposite of division is multiplication. So you just multiply both sides by that number to get your answer. So in this problem here, I have a one-step equation that has addition. So the opposite of addition is subtraction. So I'm going to subtract this 582 from both sides of the equation. And if it helps you, you can draw a line down the equal sign so you're sure to get it from both sides of the equation. And so here, when you take 582 minus 582, that's 0. So that leaves us with nothing there. So we can just cancel those out. And we're just left with x on this side. And that's going to equal. And then when you subtract 1,482 minus 582, that's going to leave you with 900. So now I'm done with the problem. X equals 900, which is going to be B. And you can always check your answers in these by substituting this value for X, our answer, back in for X. So it just means I'm replacing X with 900. So I would see, does 582 plus 900, does it actually work out to equal 1,482? And it does here. And it might help you to actually write it vertically instead of horizontally, and you can see it does equal out. Here's another addition problem using decimals. So I'm going to draw my line down the equal sign so I keep track. I have addition, so the opposite of addition is subtraction. I'm going to subtract both sides by this 5 and 66/100. And remember, when you are adding or subtracting decimals, you need to line up the decimal places in your answer. So here, 5.66 minus 5.66, that's 0. So these are going to cancel out, and I'm just left with x. And x here is going to equal, and I do the subtraction, that's going to be 2. I have to make this a 13 and borrow. 13 minus 6 is 7. Bring down the decimal. 8 minus 5 is 3. So that's what x is going to equal. Choice D, 3 and 72/100. And you can always check that by adding your answer plus the 5.66 to make sure that you actually get 9.38. Here I have fractions in my problem, which that's nothing to be scared of. You can handle it. I'm going to start off by drawing the line down the equal sign so I keep track of my two sides. And I have addition, so that means I'm going to be subtracting the number from both sides. So I'm going to be subtracting 1/6 from both sides. 1/6 minus 1/6 is 0, so these just cancel out to nothing, and I'm just left with x equals on the right side. And then I need to subtract 1/5 minus 1/6. However, when I am adding and subtracting fractions, I need to have a common denominator. So the common denominator between 5 and 6 is going to be 30. And so to make the bottom 30 on the top, I have to take 5 times 6. So I'm also going to have to multiply 6 on the top. 1 times 6 is 6, so 1/5 is equivalent to 6 over 30. And then 1/6, to get to 30 on the denominator, I have to take 6 times 5, which is 30. And I have 1 times 5 also on the top, and that's going to be 5. So I'm actually subtracting 6 30s over 5 over 30. And when you add and subtract fractions, you must add or subtract the tops and then keep the bottoms. 6 minus 5 is 1. And then you keep the bottom, which is 30. So that's what x is going to equal. And that's going to be my final answer, D. And remember, you can always check it by taking 1/6 plus 1 over 30 and seeing if that does equal 1/5. Now I have subtraction on the same side as the variable. So here I have y minus 20 on the right side. The opposite of subtraction is addition. So I'm just going to add 20 to both sides. 13 plus 20 is 33. That's going to equal negative 20 plus 20. That cancels out to 0. So I'm just left with y on the right side. So my answer here is 33, which is A. And I can always check that by taking 33 minus 20. And that checks out to be 13. So I know for sure that A is my answer. This problem here, I have a 17 right beside the x. And remember, when there's no operation shown, that's implied to be multiplication. So the opposite of multiplication is division. And I'm going to divide both sides by 17. 17 divided by 17 is 1x. However, mathematicians, we try to write things as small and succinctly as possible, so we don't write the 1. We just write x by itself, and that's implied to be 1x. And then you have to take 1,615 divided by 17. So you're probably going to have to go off to the side and work that problem out using long division. So 17 can't go into 16. It's too big. So 17 goes into 161 9 times. And 17 times 9 is 153. So I'm going to put that underneath my 161, and then I subtract that, and I'm left with 8, and then I bring down the 5, and 17 goes into 85 5 times, because 17 times 5 is 85. So I put a 5 here, and an 85 here, and when I subtract those, I get 0. So that means that there is no remainder, and x is going to equal 95. So that's going to be my final answer, which is C. Here's another multiplication equation. Remember, if there's no operation, that's assumed to be multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 2/10. These cancel out to 1. So I just have that single x on the left, and that's going to equal, and I'm going to have to go over here and do long division to figure out what 526 hundredths divided by 2/10 is. Now remember, when you're dividing by a decimal, you have to move that decimal over first. And I moved that divisor's decimal over 1, so I have to move the number under the dividing sign over 1 also. And then the decimal is going to be right above in the answer. So that's why I went ahead and drew the decimal in there in my answer. So now I have 2 divided by 5.26. So I'm going to look, 2 goes into 5 2 times. 2 times 2 is 4. I subtract those and I get 1. I bring down my 2. 2 goes into 12 6 times. 2 times 6 is 12. I subtract those and I get 0, and then I have to bring down that last 6. 2 goes into 6 3 times. 3 times 2 is 6, and I subtract those and I get 0. I don't have any numbers to bring down, so my remainder is 0. So that means x here equals 2 and 63 hundredths. So that's going to make my final answer C. Here's another multiplication equation. However, this one has fractions in it, so we have to remember our fraction rules for multiplying and dividing. I'm going to divide both sides by the 1/50th. And on the left side, 1/50th divided by 1/50th is 1. So that cancels out to that single x equals, and then remember, when you're dividing fractions, you change it to multiplication and flip the second fraction. So the second fraction is always going to be this one you're dividing by on the bottom. So that means you're going to have 1/10 times 50 over 1. And then you multiply the tops and multiply the bottoms. 1 times 50 is 50. And then 10 times 1 is 10. 50 over 10, I can divide a 10 out of both of those. And I'm left with 5 over 1, which is just 5. So that means x equals 5 here. That's going to be my final answer, B. Now I have a division equation. I have division over here by the variable, and the opposite of division is multiplication. So I'm just going to multiply both sides by 8. And this is going to cancel out to 1 again. So once again, I have that single 1y equal to, and then 6 times 8 is 48. And that's going to be my final answer, B. And you could always check it by taking 48 divided by 8, and that equals 6, which is what we needed it to equal, so it checks out. This last problem is also a division problem. So the opposite of division is multiplication, so I'm just going to multiply both sides by 12. Here, those are going to cancel out to 1 again, and I'm left with just that single 1y equals, and then I have to do 11 times 12. Which 11 times 12 is 132. And if you don't have that memorized, you could just work it out, and that's going to make my final answer B. And once again, you could check that by taking 132 divided by 12. Thank you for joining us today, and I hope you learned something new.